Okay. First of all, sorry for last week. Hari Khamis ada emergency. So hopefully kamu dah tengok video yang saya dah letakkan dalam YouTube. Saya amat berharap kelas E39, E40 dapat tengok YouTube tu dulu. And kalau ada apa-apa masalah boleh bincang dalam U-Future ya. Kalau ada apa-apa. Basically apa yang saya ajar dalam U-Future pula. YouTube tu memang dah merangkumi dengan soalan-soalan. Normally when I present in the class, it's only based on factual. Okay, without any question, without any discussion about questions. Okay, so itu yang saya buat dalam session Google Meet. Okay, during the Google Meet, I will do the examples. So dalam YouTube tu saya dah letakkan siap-siap. Actually saya memang buat video tu purposely untuk kelas korang. But bila saya dah buat, saya akan bagi tahu pada semua lah. Okay. So if you do have a questions, again tolong letakkan apa-apa masalah di dalam U-Future, forum U-Future saya ya. Masuk kat U-Future, cari forum tu, letaklah ada masalah apa, pemahaman kat situ tak faham ke, boleh letak. Especially when our time or time Google Meet dah habis kan. So hopefully semua boleh letak dekat situ lah. Okay. Ini ada soalan ke sebelum kita mulakan hari ni? Saya expect yang tu kelas yang sudah dah settle hopefully kamu pun boleh catch up dengan cepat sebab kamu kena buat tutorial 1. So if you don't watch the YouTube, so memang awak akan ada masalah untuk nak jawab tutorial 1 ya. Right. Anyone? Ada ke? Hello, boleh dengar suara saya tak?
Boleh sir.
Boleh sir.
So please respond jangan bagi saya tanya banyak kali. Okay, tolong respon. Sebab nanti aku cakap seorang-seorang nanti. Okay, so please respond. Kalau saya tanya dia boleh jawab tak. I know you have a very tiring class before this 2 to 5. So please make sure okay, kamu ada cara lah nak ni, because our class is at 5. Okay, hari Khamis pula pukul 3 sampai pukul 5. Memang masa yang agak tak best nak belajar kan. Alright. But in the end kamu kena lah buat juga ya. So please find the right time to study physics. Alright, tak perlu lama pun. Okay. So any questions regarding our lessons on last week punya? Ada tak soalan-soalan saya nak tanya? Kalau tak ada, saya akan play video untuk minggu ini sekejap dan saya akan bagi kamu tengok for a moment, 50 minutes and then afterwards kita akan sambung terus. Boleh?
Boleh. Boleh sir.
Boleh.
Boleh sir.
Tak ada apa-apa soalan sir.
Baik.
Welcome and good day students. Today, let's
tengok
talk
dulu
about
video ni.
physics in mechanics, focusing on motion in one dimension. So we are going to start with identify all the subtopics in the chapter 2. Let's begin with the first subtopic 2.1, discussing about parameters involved in a linear
Dengar
motion,
tak?
such as displacement.
Dengar sir. Dengar.
2 is about motion diagrams. 2.3 is one-dimension motion with constant acceleration. And lastly, 2.4 is free-falling object. But the subtopic 2.4 will be discussed on the next video. In order to study all the subtopics given, there are 4 learning outcomes need to be achieved by the student at the end of the session. Number 1, students should be able to define all the parameters for the motion in one dimension, such as position, distance, displacement, average speed, average velocity, and average acceleration. Number 2, students should be able to calculate all the parameters involved in the linear motion. Number 3, students should be able to apply 4 kinematics equation of motion with constant acceleration when solving the problem. And last one, number 4, students should be able to sketch, analyze, and use the graph of displacement versus time, a graph of velocity versus time, and last one, a graph of acceleration versus time when solving the problem related to a body with a constant acceleration. Motion involves the displacement of an object from one position in space and time to another position. To explain about this motion, we require a coordinate system with a specific origin. Position can be defined in terms of one frame of reference. It is a choice of coordinate axis that will define a starting point for measuring the motion. In this chapter, we focus on one-dimensional motion only. So you may choose your motion either along x-axis or y-axis. For example, an athlete walks along x-axis as shown in the figure. A displacement is defined as the change in position between initial and final position. It is symbolized as delta x. To calculate the displacement, you may use the formula as displacement delta x equals to final position xf minus initial position xi. The SI unit for displacement is in meter. Displacement is an example of vector quantity, but distance is the total length of travel object. It has the same SI unit with the displacement, which is in meter. This is example of displacement. We have two situations given. The first situation is from point A to point B. For example, if the car moves to the right from position A at 30 meter and stop at position B, which has 52 meter, the displacement of the car, delta x, becomes positive 22 meter. We say that the displacement is positive, and this indicates the motion was in the positive x direction. Meanwhile, the second situation is from point C to F. For example, if the car moved to the left from position C at 38 meter and stop at position F at negative 53 meter, so the new displacement delta x of the car now is negative 91 meter. We say that this displacement is negative and indicate the motion of the car was in the negative x direction too. Any measurement of object can be classified into two groups of quantities. The first one is scalar quantities, which are completely described by magnitude only, for example, speed and distance. The second group is vector quantities, which need both magnitude or size and its direction. For example, displacement, acceleration, and velocity. Speed is a scalar quantity. For example, Ahmad drives his car at a speed of 90 km per hour. The SI unit for the speed is meter per second. What is average speed? Average speed of an object is defined as the total distance traveled divided by the total time elapsed. By the formula, you may write average speed V equals to path length D over total time taken T. Average speed totally ignores any variation in the object's actual motion during the trip. Both magnitude of path length and the total time taken are always positive. As the result, the speed or average speed also will become positive. The SI unit of the average speed is meter per second. So now, what is the difference between the path length and distance of a moving object? The distance is the length of a straight line joining between the 2 points. The distance depends only on the endpoints, but doesn't depend on what happened between these points. So we can say that distance is the magnitude of displacement. However, the path length or total distance traveled is the length of an actual path traveled across between the 2 points, including any retracing of the step. The path length will depend on the actual route taken during the trip. Velocity is a vector quantity having both magnitude and direction. When a moving object undergoes a displacement and takes time to move, we say that the object has a velocity. So that velocity can be both positive or negative regarding to its direction. The total time taken during the motion must always be positive. Average velocity is the rate at which of displacement occurs. By the formula, you may write average velocity equals to displacement delta x over change of time delta t, or displacement delta x equals to final position xf minus initial position xi divided by final time tf minus initial time ti. Average speed is not same as average velocity, but these two quantity has the same SI unit, which is in meter per second. Average velocity is also a vector quantity. It tells us how far something is moving with the direction of the object. If an object is moving in the positive direction, the magnitude of average velocity is greater than 0. This is because of the final position must be greater than initial position. Otherwise, if an object is moving in the negative direction, you may get the average velocity less than 0. This is because of the final position now must be shorter than initial position of the object. Velocity can be determined from position versus time graph. We plot position x on the y-axis and time t on the x-axis. The magnitude of average velocity equals to the slope of the graph. If an object is moving with a constant velocity, the graph shows a straight line. To calculate the slope of the graph or the average velocity from the graph, the student may use the formula as the change in vertical axis, delta y, divided by the change in horizontal axis, delta x. When the moving object changes its velocity, we may have a curved path graph. This motion is called as non-constant velocity. Therefore, a position versus time graph is not a straight line graph due to the changing of the velocity. The magnitude of average velocity is the slope of the graph. To having this, student needs to draw a straight line from initial point to final point, as shown as the blue line on this graph. The instantaneous velocity can be defined as the average velocity in the limit as the time interval becomes infinitesimally short. The magnitude of instantaneous velocity can be calculated from the slope of the graph displacement x versus time t. The slope of the blue line shows that the average velocity which approach the slope of the green tangent line, which is the instantaneous velocity. Next is acceleration. Acceleration is symbolized by small a. By definition, it is changing of velocity, or we may say that acceleration is the rate of change of the velocity. To calculate the acceleration, we may have the formula acceleration a equals to change of velocity delta v divided by change of time delta t. Or you may write as acceleration a equals to final velocity vf minus initial velocity vi over final time tf minus initial time ti. The SI unit of acceleration is meter per second squared. You may also use the others unit such as centimeter per second squared and feet per second squared to indicate the acceleration. Acceleration is a vector quantity having both magnitude and direction. When the velocity and acceleration are in the same direction, then the speed of the object will increase with time. Therefore, the object is speeding up. Otherwise, when the object velocity and acceleration are in the opposite direction, the speed of object now decreases with time. We may say that the object is slowing down or decelerate in its motion. So students, please remember that a negative acceleration doesn't mean the object is slowing down. For example, if the acceleration and velocity are both in negative, the object is speeding up. Deceleration means a decrease in speed, not a negative acceleration. The instantaneous acceleration is the acceleration of a particle at a particular instant of time, not during a finite time interval. It is also defined as the limit of average acceleration as the time interval goes to 0. The closer the time interval delta t gets to 0, the closer ratio of delta v over delta t gets to a fixed number, which is the instantaneous acceleration. To find the average acceleration from the graph, we need to have a graph of velocity versus time. The slope of the line connecting the initial and final velocity represent the magnitude of average acceleration. Meanwhile, the instantaneous acceleration can be calculated from the slope of the tangent to the curve of the velocity versus time graph. The explanation for both average acceleration and instantaneous acceleration can be shown from the graph of velocity versus time. As you can see here, the slope of the green line is the instantaneous acceleration of the object. Meanwhile, the slope of the blue straight line between point P and Q is the average acceleration of the object. A motion diagram is a representation of a moving object at the following time intervals, with the velocity and acceleration vectors sketched at each position. Red arrows for velocity vectors and the violet arrow are for acceleration vectors. The time interval between the adjacent position of the car are assumed same. Diagram A shows the car moved the same distance in each time interval. Therefore, we can say that this car moved at the constant velocity and has zero acceleration. The diagram B shows the car is speeding up. This is because of the velocity of the car increases with time. This car has a constant acceleration in the direction of its velocity. And lastly, diagram C telling us about the car is slowing down or decelerate in its motion. This car has a constant acceleration in the direction opposite of its velocity. A particle moving along the straight line on the x-axis with constant acceleration can be studied on the three different graphs. The first graph is graph acceleration versus time. As you can see here, the slope is zero. This is due to the constant acceleration between the initial point to end point. When we calculate the area under the graph, we may get the velocity of the object. The second graph is graph velocity versus time. It has a straight line graph, meaning that the slope of the graph has a constant acceleration. When we calculate the area under the graph, we may get the displacement of the object. The third graph is graph position versus time. When we calculate the slope of the graph, we may get the velocity of the object. Before you start solving the problem in one-dimension motion, let's identify four kinematics equations involved. So student, please remember these four equations are used in the situation that has uniform or constant acceleration only. The first equation is V equals to V naught plus AT. The second equation is delta x equals to V bar t. The third equation is delta x equals to V naught t plus half AT squared. And the last number 4 is V squared equals to V naught squared plus 2a delta x. V stands for final velocity. V naught stands for initial velocity. A is for acceleration, T is for total time taken, delta x is for displacement, and V bar is for average velocity. To understand and apply these four equations, let's do the exercise from the textbook.
Okay, so how is it? Boleh faham tak dengan video tersebut?
Boleh.
Okay. I think you already learned this thing during your school days.
Boleh.
Okay. Oh, lambat sikit. Okay, but I just want to highlight a few things, especially to the examples. Okay, let's go to the examples first, and you will look to the examples. Okay. So let's say this one is I'm using my slides. Okay, you can find these slides in the future. Okay, I put under my name or under my folder. So basically, you should understand how to differentiate between displacement and distance. Okay, and of course, the displacement is the change in position, which means you have xf or final position minus initial position. Okay, but for the distance, it's actually the total road taken. Okay, the total length taken. So that is what we call as distance. So the distance is a scalar quantity, therefore, while displacement is a vector quantity. The difference between vector and scalar quantity is just a direction, meaning that displacement you must be able to understand there is some direction involved in the measurements. Okay, so how about velocity? Okay, normally when we talk about velocity, we always talk about speed, because speed and velocity is definitely have only small margin. Okay, because speed is actually velocity, but speed is only for scalar quantity, but velocity is for a vector quantity. Okay, the difference between scalar and vector, again, with the directions. And of course, for speed, it only focus on the distance, while for the velocity, it will focus on the displacement, right? So the unit for the velocity or speed is J. SI unit is m over s, which means a meter over seconds. Okay, so let's look at this example. A turtle and a rabbit engage in a foot race over a distance of 4 kilometers. The rabbit runs 0.5 kilometers and then stops for a 90-minute nap. Upon awakening, he remembers the race and runs twice as fast, finishing the course in a total time of 1.75 hours, and the rabbit wins the race. Okay, ini bukan macam cerita dongeng lah. Ini memang pasal cerita rabbit menang, turtle tetap kalah. Okay, walaupun rabbit dah tertidur selama at about 90 plus minus 90 minutes nap. And of course, calculate the average speed of the rabbit. Okay, average speed of the rabbit. So meaning that total distance over total time. How many distance? 4 kilometers. And how about time? Okay, kita ambil ayat dia, finishing the course in a total time of 1.75 hours. So kita ambil kat situ elapsed time dia 1.75. So therefore, total time over total displacement, total distance over total time, then you will get 2.29 kilometers per hour. Okay. Does we need to change it to the SI unit? Perlu ke? Tak perlu?
Perlu.
Okay. Perlu ke tak perlu? Kali kawan macam tu perlu kan? Perlu ke tak?
Tak.
Okay. Seboleh-bolehnya tukarlah jawapan akhir at least kepada SI unit. Kecuali dalam soalan tu memang dah mention answer your final ataupun give your answer in kilometer per hour dan kena ikut. Okay, tetapi kalau macam dalam kes ini, dia sebenarnya dia calculate halfway lah. Dia dah kira kilometer, dia diberi kilometer, dia ada hours, so dia guna, dia dapatkan kilometer per hour. Of course, the value will be smaller when they convert it to meter per second. Kan, so smaller ataupun bigger ke tak kisah, tapi akan ada perubahan. Right. Soalan kedua, what was his average speed before he stopped for a nap? Okay, what was his average speed? So maksud dia berapa kelajuan dia semasa dia sebelum dia nap, sebelum dia tidur. Okay, yang tu kita tak tahu, yang which is kita nak cari. Yang selepas dia bangun, dia tak cakap juga berapa kelajuan dia, tetapi yang kita faham, dia berlari 2 kali lagi laju daripada yang dia datang tadi. Yang masa dia sebelum dia tidur. So that is what happened to the rabbit. Okay, he remembers the race and runs twice as fast. Okay, jadi kenapa macam mana dalam soalan ini tiba-tiba dia keluar macam ni? T1 plus T2 equals to 0.25 hours. Mana datang 0.25 hours tu? Dan kenapa? Apa kaitan dia dengan time? Boleh siapa-siapa bagi tahu saya? Awak faham kan situation dia kan? Situation dia rabbit dengan turtle berlari. Okay, selepas 0.5 km which is 50 0.5 500 kan, 500 meter, dia berhenti dan dia tidur selama 90 minit. Bila dia tersedar, okay, dia pun lari 2 kali lagi laju daripada yang dia dah masa sebelum dia tidur, and dia dapat berjaya selesaikan 4 km tu dalam masa 1.75 hours. So total time dia 1.75 hours. So apa kaitan 0.25 ni? Siapa tahu? Anyone nak try?
1 kilometer 0.2.
Macam mana? Okay. Soalan ni soalan lebih tricky. Kenapa? Bukan tricky lah, maksudnya dia soalan menipu. Soalan dia kalau kita tengok kan, velocity langsung tidak diberitahu dalam soalan. There is no mention about velocity. Okay, but it did mention about time. So from time and distance ada, therefore daripada situlah kita nak dapatkan V. So that's why from time taken, okay, sama dengan 0.25. 0.25 ni bersama dengan apa sebenarnya? Kalau awak tengok jumlah dia dalam one.
Masa dia betul-betul lari. Dia
Betul.
tolak waktu tidur
Sebab
dia.
dia berlari selama 1.75 hours, and bila kita convert 90 minutes tu bersama dengan 1.5. 1.5. Macam mana nak convert 90 bagi 60? 90 bagi 60 dapat 1.5. Jadi dia tidur selama 1.5 jam. Bila tolak dengan 1.75 jam, jadi yang dia berlari sebenarnya ialah 0.25 sahaja. Tapi 0.25 tu termasuk dengan jumlah yang dia lari sebelum dia tidur dan jumlah yang dia lari selepas dia dah tersedar. So ada dua masa dia kat situ. Okay, so that's why dia ambil guna T1 plus T2. And of course, okay, ambil distance 1 over V1, which means distance 1 is 0.5 divided by V1, and distance number 2 is 3.5 km. Tengok kalau tambah 0.5 dengan 3.5 ni dapat 4 km. Okay, but he run twice as fast as before he nap. Maksudnya dua kali lagi laju, dua kali V1. So that's why dapat jawapan dia 9 km per hour. Faham tak?
Faham.
Good. Okay. So teruskan. Average velocity again, total displacement over total time. The unit is still meter per second. Okay, graphical interpretation of average velocity. Alright. So how to connect between average velocity and what is instantaneous velocity? Average velocity kita dah biasa, average speed kita dah biasa. Tapi ini apa dia? Instantaneous ni maksud dia apa? Kalau kita tengok dia punya definition dia, V equals to limitation of delta T approaching 0, AX over AX pula. Delta X over delta T equivalent to dx over dt. So the meaning is the instantaneous velocity is the same, is the velocity that we want to measure or we want to calculate based on a certain point of view, which is dalam keadaan sekarang kita nak tahu at time 2 seconds apa yang jadi pada velocity, at 3 seconds apa akan jadi pada velocity, what happened to the velocity when the time is 10 seconds contoh dia. Okay, nak lebih faham kita akan tunjukkan dalam bentuk examples. Okay, let's say we do have train that move slowly along a straight portion of track according to the graph of position versus time. Okay, ingat tadi Madam tu ada mention pasal dua graph. Okay, yang pertama position over time, which mean X versus T, dan juga yang kedua V versus T or velocity versus time. Okay, so dia nak tahu yang pertama the average velocity for the total trip. Okay, the average velocity for the total trip, which means the total displacement or the total distance berapa? Tengok dia dah start daripada kosong, dia lalu macam-macam mana pun tapi dia still sampai ke 10 juga, 10 meter paling maksimum. So that's why total displacement atau displacement ialah 10 meters. Okay, sebab kita ambil titik akhir tolak titik awal. Okay, 10 tolak kosong. Okay, untuk time taken again daripada sini 12 minus 0. So 12 minus 0 equivalent to 12 seconds. So we dapat, okay, kita ambil calculator, hanya partial calculator about 0.833 meter per second. Okay, yang B, the average velocity during the first 4 seconds of motion. Where is the 4 seconds of the motion? Tengok daripada yang belah kiri, tengok yang belah kiri. Daripada O kepada A. Okay, daripada A kepada B, daripada B kepada C. So O kepada A duduk di antara jadi Macam Madam tu cakap tadi, what does it mean by the slope of the position versus time graph? Dapat apa? Dapat velocity. Okay, dapat velocity. So that means we have to divide the total distance over total displacement over total time. So 4 bagi 4 dapat 1. Kalau ada siapa tak faham, bagi tahu Laju sangat ke saya cakap macam Madam tu tadi? The average velocity during the next 4 seconds of motion. The next 4 seconds will be from point A to point B. Ini jangan tengok yang belah kanan tengok figure A dulu. Okay. Point A meaning that daripada 4 seconds to 8 seconds. Kalau kita tengok dia duduk pada satu garisan yang rata. A very flat face, flat line. Therefore, there is no average velocity. Maksudnya dekat situ dah tak ada average velocity. The next 4 second Sebab apa? Kosong. Kosong bahagi dengan 4 still akan dapat kosong. Okay. Now D, the instantaneous velocity at time t. Nampak soalan dia selalu the instantaneous velocity at time t equals to 2. So dia lebih spesifik. Kalau tengok instantaneous velocity, instantaneous acceleration, dia lebih spesifik kepada setiap soalan. Okay, contoh dia. Nah ini dia tanya dekat time t equals to 2. Carilah dekat figure time t berapa? T equals to 2 seconds. Then you project ke atas biar dia betul-betul kena dekat graf tu. Oh, rupanya dia duduk di atas line OA. So therefore dia ikut macam jawapan A tadilah. Equivalent to 1 meter per second. Okay, macam jawapan B. Macam jawapan B. Alright. Number B and E, the instantaneous velocity at time t equals to 9. Dekat mana? Antara 8 dengan 10. Masih lagi pada figure A. Tengok pada 8 ke 10, tengah-tengah ialah nombor 9. So bila kita project ke atas, tiba-tiba dia terkena dekat satu graf yang berbentuk curve. A very curvy graph. So nak tak nak, we have to make sure that we have to set up a triangle dekat situ. Kena buat triangle, kena buat apa kita panggil tu, a tangent line. Tangent ni maksud dia satu garisan yang bersentuhan dengan permukaan yang bulat ataupun permukaan yang curve. So that's why we call that as tangent line. So it touch that point at that particular curve, so kita akan dapatkan dia punya new gradient. So in this case, new gradient dia equals to 0.75 meter per second. Okay, senang je, tak ada masalah. Right, so ini juga dia boleh tanya pasal instantaneous velocity, gains. Okay, tengok X versus T. Soalan dia, a jet engine move along an experimental track. Okay, we will treat the engine as if it were a particle. Its position as a function of time is given by the equation X equals to AT square plus B. Okay, dalam kes ini dia bagi equation, dia tak bagi graph, tapi in the end kita plot juga graph. Okay, cuma dia bagi dalam bentuk function. Masuk function tadi itulah dia, X equivalent to AT square plus B dan sebagainya. Which in this case A is 2.1 and B is 2.8. So soalan dia, determine the displacement of the engine during the time interval of 3 seconds to 5 seconds. So bila dia minta apa? Displacement. Displacement memang X. So ganti je lah tempat-tempat T tu dengan 3 dan gantikan tempat T tu dengan 5. And then of course kita akan tolakkan dia antara X2 minus X1 because that what the displacement is all about. Okay, you ambil titik hujung dengan titik paling awal. Titik paling hujung ialah 5 seconds, habiskan dengan 3 seconds. So dekat situ beza dia ialah 33.6 meters. Okay. Soalan B, determine the average velocity during this time interval. Okay, during masa 3 to 5 seconds. What is the average velocity? So average velocity again menggunakan equation delta X over delta T. So dapat 16.8. Betul-betul dekat point di mana 3 and 5 seconds have been plot. We get 16.8 meter per second. Of course, there will be varied in terms of final answer, akan ada sedikit perubahan, especially curl lah, dia tak sama semua. Ada orang buat curl dia flat, ada orang buat curl dia ada lengkung yang sangat banyak. So, tak boleh macam tu lah. Okay, that's why biasanya kita akan tengok soalan dia. The last part will be the instantaneous velocity of time t equals to 2 time t2 equivalent to 5 seconds. Okay, so dia nak cari instantaneous velocity at time t equals to 5. So how to do it? Again, tengok cara dia buat. X equivalent to AT square plus B. X tu apa? X tu ialah displacement, tapi as a function of time. So how to do it? So V ialah apa tadi dia cakap? Instantaneous dx over dt. So we need to do a differentiation to get V. So bila dah differentiate dapat apa? Dapat 2 AT. 2 kali A kali T. B hilanglah sebab B tak ada T. Right? So gantikan dengan T tu dengan 5 seconds. Therefore we get 21 meter per second. Okay? Ada soalan so far? Soalan ke?
Ada.
Ada ya? Ada, okay. This is acceleration. Okay, so acceleration again delta V over delta T. Acceleration pun dia macam tu lah. Dia ada average acceleration dan dia juga ada instantaneous acceleration. So dua-dua pun ada. Tengok unit dia meter per second square. Meter per second square. Okay, sometimes centimeter per second square. Anything yang belah bawah denominator part is square, so that is always related to, normally always related to acceleration. When belah atas tu ialah length, definitely memang ikut acceleration. So that's why kalau kita esok jumpa pelik-pelik kan dia punya unit tu, jangan digabra, relax je. Kita tahu lah kalau square dia definitely memang acceleration. So this is increase in speed and of course the decelerations. And of course, there will be average acceleration, which means the instantaneous acceleration. So where is the instantaneous acceleration? Again, how to build up the tangent to the line. Okay, so let's look on the last part of the example, the last examples for today. A baseball player move in a straight line path in order to catch a fly ball, a hit to the outfield. His velocity as a function of time is shown in figures. Find his instantaneous acceleration at point A, point B, and point C. So point A kamu tengok duduk kat mana tu? Duduk kat antara beberapa, memang betul-betul semua duduk di atas line yang sama, cuma ada beberapa tempat yang tak sama. Okay, in this case, part A ialah apa? So gunalah kebijaksanaan untuk buat cari dia, memang gradient dia lah tu. 4 minus 0, 2 minus 0. So therefore dapat 2 meter per second square. And how about B? Point B bukan B yang jawab tu. Point B ialah duduk di atas permukaan 4 meter per second dan 4 meter per second. Nampak macam mana dia tulis? Dia kalau dia faham dia terus tulis kosong, tapi sebabkan dia nak dapat markah, dia nak rasa biasakan diri dengan latihan macam tu, so they need to put the 4 minus 4 divided with 3 minus 2. So in the end, okay, we have to program our mind so that we will always put the units. Okay, don't forget about the equations and the substituting the values. Okay, so the answer is 0 meter per second because of flat. And how about C? C duduk pada jarak turun ke bawah. Okay, 4 minus 2, 4 minus 3. Okay, 4 minus 2, 2 minus 4. Okay, 2 minus 4 again. Final dia siapa? Initial dia siapa? Dalam case ini, final dia ialah 2. Initial dia ialah 4. So that's why dia guna terbalik. 2 minus 4, 4 minus 3. Tapi ingat, kalau dia bentuk macam tu, dia akan ada negatif. Alright, so and the last part of it is how you must handle the constant acceleration. What does it mean by constant acceleration? So constant acceleration ni, acceleration pada soalan itu memang maintain pada satu value yang sama sahaja. Contoh dia 8 meter per second square. Tu je lah value. Sebab tu biasanya dalam soalan-soalan macam ni, acceleration biasa dia cari ujung, dia cari kemudian. Sebab memang acceleration tu nilai dia tetap. That's why dia katakan constant acceleration. So kalau situation dia constant acceleration sahaja, then equation ni boleh pakai. Kalau tak, pakailah ikut cara graph, pakailah ikut cara limit, pakailah ikut cara nak tengok daripada slope dan sebagainya. Okay, this question yang kamu hafal ni, V equals to V0 plus AT, delta X equals to V0 T plus half AT squared. Okay, V square equals to V0 square 2A delta X. Don't get confused. Kat sekolah kita gunakan VU dengan S. Di sini kita tak guna VU dengan S. V masih V final, tapi V0 tu kita, U tu kita tak gunakan U. Kita gunakan V0. That means initial velocities. Okay, and how about S? S memang tak ada sebab S tu satu huruf saja. Okay, the very short form of S. Tapi sedangkan S punya tempat ialah apa dia? Ialah titik akhir tolak titik awal. Final position minus initial position. Okay, remember that is the delta X over here. Okay, alright. So we will use this example on our next class. Ada soalan tak? Masa sekarang? Do you have a questions or not?
Tak ada.
Tak ada sir.
No.
Okay, I should remind you about your quizzes will be on third week maksudnya minggu depan akan ada quiz. Okay, quiz yang semua orang kena hadap lah. Minggu ketiga dah ada quiz, so tolong study awal-awal and of course
Ada sir.
untuk apa dia? Apa yang ada tu? Hakimuddin? Hakimuddin?
Yes sir.
Kamu
Tak ada,
tanya apa
sir.
tadi?
Dia tak dengar.
Oh.
Dia
Oh.
tak ada soalan sir.
Ya. Lama sangat tu dia punya lagging tu. Okay. So nanti we'll see you on the next class hari Khamis. Okay, I'll try to finish up. Make sure you watch the video first. Okay, mungkin kita dah tak perlu tayang video sebab ni lepas ni tolong tengok video lagi supaya kamu boleh ingat the formulas dan sebagainya. And please, okay, kalau ada video-video saya akan cuba letakkan lebih awal lah supaya kamu boleh tengok. Of course, this session for those yang tak boleh tengok tadi, macam Muaz bagi tahu ada kawan tak dapat nak view, tak dapat nak tengok dalam Google Meet sebab data dah habis, saya akan upload ke dalam saya punya YouTube channel. So tolong make sure dia tengok dekat situ lah. Okay. Any more questions so far?
Sir,
Yes.
nak tanya, dalam calculation perlu letak unit?
Dalam calculation tak perlu. Dalam calculation tak perlu nak letak unit yang panjang-panjang semua, tak perlu. Final answer yes. Adam.
Thank you.
Okay.
Saya nak tanya, slide tadi tu boleh saya dapat kat mana?
Yang
Saya
mana?
akan post kat GC slide
Yang
yang,
mana?
saya tunjuk tadi.
Yang saya punya yang ada soalan tu ke?
yang ada soalan tu.
Yang ada soalan tu boleh tengok kat YouFuture saya.
Alright, thank you sir.
Masuk kat YouFuture, you can see. Tengok dekat situ. Any more questions?